and various statistical techniques relevant to biomedical research. We're truly honored to have with us a very accomplished speaker for the session today, Mr. Tapaste. Welcome, sir. Mr. Tapaste is a doctoral fellow at the prestigious Institute of International Institute for Population Sciences in Mumbai, in the Department of Biostatistics and Demography. He holds a BSc in Statistics along with the MSc and MPhil in Biostatistics and Demography. He has received specialized training in health and demography research and has made significant contributions to the field. Mr. Day has previously worked as a research officer on a project funded by the Bill and Melinda Gates Foundation in collaboration with the Population Council, New York. He has also been associated with the Population Studies Unit at the Indian Statistical Unit, Kolkata. Currently, as he pursues his PhD at IIPS, his research focuses on understanding demographic transitions and health outcomes in context of evolving family structures in India. We are thrilled to have him here to simplify and share this essentials of biostatistics with us today. So without further ado, I welcome Mr. Tapaste to take over the session.
Okay, thank you. Thank you so much. I will share my PPT and may I start? All join.
Yes, sir. Yes, sir. You start.
Okay, okay. Is it visible? My screen?
Yes, sir. It's visible, but it hasn't opened. PPT is.
Oh, it is visible to everyone?
Yes, sir. It's now.
Okay, okay. Thank you for organizing such a nice workshop. It is really essential. I think most of you are from medical background. And this topic is actually it's not kind of 1.5 hour or within 2 hours. Actually, long term it's time is required for thus illustration and explain what these uh, things actually. So now I will briefly at first I will explain a little bit why this comes into the picture, the importance of biostatistics, little a bit, and after that, the main focus of this session, this sampling method, calculating sampling size, and this sampling, this analytical things, how we can use this statistical implementation in the bio or health related. So first, if I become, acha, most of you are from medical background. May I know these things?
Yes, sir.
Means
Yes,
which
sir.
kind of background students are included in this session?
So medical students, interns. So,
Okay, okay, okay. So most of you, I think you have read some community medicine related or this famous Park and Park and or this kind of books, CDCs, manuals, kind of. But actually, the domain of biostatistics is very large, and in mainly in India, that's not too much research work is going on. Mainly in Western countries, we are engaging also is uh, so much works based on human-related things. So, if we see the importance of biostatistics when comes from mainly from the statistical things, and it's usually in the fields of the medicine and the public health. If we know everyone, this one very much interesting study happened in London that is called cholera.map, and this was done by John Snow. And in that time, nothing means no biomedical or statistical tools we had in that time. But in that time, Jon Snow introduced some graphical representations where the uh, these problems originated, and the most of the people, they were is having some kind of health related issues due to due to some contamination of water. So this was the first step when the importance of biomedical research comes into the picture in our statistical field. And after that, we if we see the origin and development of statistics in medical research, that is, there are some important studies also there. In 1937, one important study that was done by Austin Bradford Hill. It is famous. He done some study on association among the smokers and the cigarettes, having cigarettes. So these are some landmark research in biomedical fields. And in 1948 also, RCT trial of streptomycin for pulmonary tuberculosis, that was also done by these famous statisticians. This after that, this fields has got uh, so much importance. So if we see some figures, kind Altman, Fisher, Pearson, an Indian statistician, C.R. Rao, those all are associated with some very famous instruments we have in statistics as well as biostatistics fields. So actually, biostatistics is the science that helps in managing our medical uncertainty. These uncertainties with data, uncertainties with values, uncertainties with the implementation, uncertainties with drugs. So with the help of biostatistical measurement, can have some tools that we can have the measured, we can have some solutions. So if we see or in health planning and evolution, so everywhere that is in carrying a valid and reliable health research analysis. So we have very good instruments in biostatistics. And if we see developing research design, actually mainly area based on or focus things. Am I audible?
So your voice is cutting.
Now I am audible.
Yes, sir.
Okay. So if we health related issues in some area, so first question comes, to whom we study, and if we have the cases, so how much cases we have to consider. So after having the cases, we have the data will be organized. After that, the questions, how we means we have to analyze in what kind of way that we can get a better interpretation of such ongoing things, how to interpret. So all these questions have some good answers with the biostatistical tools. Suppose we want to evaluate two treatments that is based on evolution of penicillin, and another one is penicillin with chloramphenicol. These two kind of treatments we have, but we want to apply it children under 2 years. So some questions in comes in our mind. What is the sample size needed to study this kind of situation? If treatment is better than treatment B or vice versa, how much better means which one will works better for which kind of population. So there are different kind of question comes into mind. Is there any normal variation in clinical measurement, or how the reliable this measurement means? which kind of statistical tools I am using. Is it reliable? Is it valid for the study which I am doing? Or how much efficient the study we are doing? So there are many kind of questions we have. So for this situation, we will use some statistical measurement. Now I am audible.
Yes, sir.
Okay.
Sir,
Hello.
sir, you're not audible.
Hello. I am audible now.
Yes, sir.
Okay. So these statistical tools covers the planning, how to plan the study, to design, how to do the study, where to do the study, and how the sample size will be calculated. After that, the data collection procedure, how to collect the data in such a way that we can control the bias. And after that, how to process the data, how to analyze the data using softwares and what other else, and how to present the data, how to interpret the data, how to inference the data, and how to publish or how to reach to the common people that they can take some uh, caution measurements. So these all have good answers with the statistical or biostatistical tools we have. Now I am audible.
Yes, sir.
So after that, I will come to the sampling method. So mainly sampling method covers or it gives the understanding of the sampling process and importance, means in which situation what kind of sampling methods we have to use and how to apply in different kind of samples or populations. So suppose we want to study on a specific section of the population. So there is no need to collect the information the overall population. We can take the samples from the population. These samples can represent the population based on their characteristics. So if everyone knows about census data, but what is the difference between census and surveys? Now, what we are saying about in this session, everything is related to survey measurements, and the sampling procedures comes in terms of survey only, not in census, because census takes the whole enumeration, means everyone in the country will be calculated based on their characteristics, means based on their socio-cultural characteristics, based on their economic characteristics. Everyone will be calculated in census, but when we comes to survey, we need have many measurements to collect the actual scenarios of these specified population. That's why we have that so much instruments or tools for having the information based on the survey mainly. So why sample? Why we are not collecting the information for the whole population? Because we have to reduce the bias, we have to save our time and money, and we have to do in such a way it should be feasible also. So there is no need to take information for the all members in the population. So sampling is the process or technique of selecting the characteristics and the adequate size. So there are different kind of samplings based on probabilistic measure and non-probabilistic measure that I will come later. So I have to collect a sample. So in such a way that the sample should be valid and should be reliable for our study. Suppose A sample should accurately reflect the distribution of the relevant variable in the population. If we are taking the person, so there is a different kind of persons with different ages, different sex, different caste, different religion, etc., economic status, wealth status, occupational status, and their depends on their health status, their place, whether it is urban, it is rural, time. We have some diseases in winter season, specific diseases in summer season. So there are different kind of situations. So we have to collect in such a way based on the study objective that the samples should be valid and reliable for our study. So sample is collected based on the sampling frame, that is based on sampling population. So will sample is represent, if we see this picture where this target population, suppose we are sitting in Mumbai, so our target population, we are having some study based on Mumbai, maybe based on some specific health issue. So our target population is Mumbai megacity, metro city population. But there are lakhs population, so it is not feasible. It is not possible to have information all the individuals within the target population. For that purpose, the sampling population will be framed based on some specific criteria that I will come into the later. For specific, there are various kind of sampling methodologies. In that situation, I will tell these things. And from this framed population, we will and based on this sampled population, we will take information, and based on this information, we will infer the or interpret the situation what is going on that place. So there is no need to define the population. We everyone know, and sample also I have told it is a representative group of the larger population that we can generalize the situation. So what is sampling frame? Sampling frame is very much important. So if we want to have the sampled population, so in that time we we should have some information. Now from where we will collect our sampled population. So that's why we need a frame of whole, based on the characteristics, the whole criteria is, uh, we all know the census, about census. So suppose any survey, uh, there is a survey, National Family Health Survey, NFHS, that is health survey. Another survey is National Sample Survey. So in India, we have various kind of surveys. So in that kind of large surveys, they all take the sampling frame as a census sampling frame, because census is a whole enumerative survey. It is not actually survey, it is a whole enumeration of population. So census have every household information in their directory. If you are there, every town information is there, every ward information is there, every.
Excuse me,
Hello,
sir. Yes, sir, your voice is breaking.
hello,
Yes, sir. So you're not
hello.
audible. Yes, sir, you're not
Uh,
audible.
right now.
Yes, sir. It's okay.
Okay. Whenever you will have some issue related to sound or other things, so you can just let me know.
Okay, sir.
Okay.
So you continue.
Okay. So, uh, so in the census population, what we can see that they take each and every individual's information in their directory. So if you go or we go to the census directory, we have every household information is there. So for the large scale surveys like NFHS, NSS, PLFS, there are various surveys is there. They all take the sampling frame as a census. From there, based on some specific characteristics, based on their research objectives, they prepare the sampling frame and they specify their sampled population. But whenever we do some small study, maybe in hospitals, maybe for our own research, it is not possible to take to organize this situation is different. That in that situation, what we can do or what we do usually, that is also I will take it later. So every sample means we are not taking the whole population. So if we are not taking the whole population, uh, I will start. No, I'm switching on, but if network issue is there related to audio, let me know. Because after switching off the video, maybe sound will like. So uh, whenever we talk about the
Sir, you're not audible.
now I am audible.
Yes, sir.
Hello. Okay.
Yes, sir.
So okay. So whenever we take any survey, so in that time we are not taking the whole population. We are taking a sampled population from the whole means for the large population from the large population. So in that time, what happens? Hence, we are not taking the whole populations. We are trying to have some similar characteristics uh, that matched with the larger population. So obviously, every individual have different kind of their characteristics, different kind of their attitude, uh, and it depends on village to village, city to city, state to state. So obviously, in the sampling, there are some errors. So that is for that errors also we have some measurement that in the statistical methods I will tell. So in that cases, uh, two kinds of errors is generated. One is for due to the sampling, is which kind of sampling we are using. So based on these sampling procedures, some errors are generated, and due to the sampled population and for their different characteristics, the variations among the individuals, there are also different kind of errors happened or we are getting within the sampled population. So that is sampling errors, first one, and second one is sampling variation. So both we will try to minimize both the error in such a way we can get a good measurement. Suppose in a clinical trial there are 200 participants, we find that the efficacy of a particular drug that is 75%. If we repeat the study using the same drug in another group of similar 200 patients, we will not have the same efficacy. 75%. It could be less than 75%, it could be greater than 75%. So different results in different trials because different means in maybe in different region, maybe
Sir, you're not audible.
hello.
Yes, sir.
It is now. Am I audible? Yeah.
Yes, sir, but it's breaking.
Okay.
So what we can do is, if you want, you can, share us the PPT on WhatsApp so that we can share it from our end, and you can just, tell us when to change the slide, and we'll change the slides. So your internet won't be, utilized. So I think that will be fine from your end.
I can share these PPTs by mail also.
Yes, so that will work for us. You can just share to us via email, and then we'll share it from our end in this meeting, and then you can let
Okay.
us know when to change the slides.
Okay. Okay. So in that time, what means what I have to do? I will share the PPTs after that. Hello.
দাদা,
Ah.
আহ, তুমি আমাকে স্লাইড গুলো পাঠিয়ে দাও, আমরা আমাদের দিক থেকে স্লাইড গুলো শেয়ার করছি, তাহলে তোমার দিকে নেটওয়ার্ক ইস্যু হবে না।
Okay. 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 Okay.
তোকে হোয়াটসঅ্যাপে পাঠিয়ে দাও, আমি আমি তোমাকে পাঠাচ্ছি। হ্যাঁ, তো বুঝলা? হ্যালো, তাপস দা,
second.
সেকেন্ড ওয়ান।
হ্যাঁ, 4টে পিপিটি যায়নি।
দুটো পিপিটি এসছে।
4টে পাঠিয়েছি।
ও হ্যাঁ হ্যাঁ, পেয়েছি। তোমার কোনটা করবো বলো? স্যাম্পল
সেকেন্ড
সাইজ ক্যালকুলেশন,
সেকেন্ড
স্যাম্পল সাইজ স্যাম্পলিং মেথড। আচ্ছা দাঁড়াও।
স্যাম্পলিং মেথড স্লাইড নাম্বার 12।
I shared you the sampling method. All four I told.
Slide number 12.
Okay, sir, you can start.
Fine. Okay. So here, at first we have to define the population. After that, we have to define the sampling frame. As I told you earlier, that it is able to find the sampling frame for the mainly for the large scale surveys, but for the small scale survey, we are for specific situation. It is not that much not important to have the sampling frame in that case, because we study very less population or kind of case study there. In that situation, sampling frame is not required. After that, we have to use some sampling technique. After that, we have to determine the sample size, how much sample we need to study the specific situation. After that, we have to execute the sampling process. Next slide. So there is mainly two types of sampling methods. One is probabilistic sampling and another is non-probabilistic sampling. Just click the second next button. So in probabilistic sampling methods, basically the four or five types of sampling methods is there, and basically for the large scale survey we employ this kind of sampling methods. It is steeple random sampling, stratified random sampling, systematic random sampling, cluster random sampling, and multi-state random sampling. Based on the situation, based on our objective and area of study. And for the non-probabilistic sampling method, that is the different kind of sampling, that is quota sampling, convenience, or purpose sampling, snowball sampling, where the it is tough to have the sample characteristics for the large scale population. So suppose we want to study the drug users. So we cannot have uh, large number of people easily, or we cannot easily access the specific place from that place we can collect a large number of drug users, or maybe for that purpose, if we want to study, we cannot employ the probabilistic kind of method where everyone have a same chance to include in the sample. So for that situation, we use the non-probabilistic sampling method. Next slide. This is a simple random sampling. Basically, what happens in the simple random sampling? Everyone have the similar probability to is have included in the sample. Suppose suppose we want to study suppose we want to study the average height of class 5 students in a school. So in that situation, the class 5 students, they have similar interval of birth year. They almost most of them have the similar kind of weight or height, and there may be some differences in them. If we study the average height of this class, we can use a simple random sampling, because there everyone have the similar probability to be included. And most of the situation when we can include this kind of sampling, when there are too much homogenized uh, individuals within that population. In that situation, everyone have the similar kind of characteristics or similar kind of attitude. So in that situation, we can easily have this kind of sampling method like lottery method, and there is also a specific random numbers table is there. Previously we used this kind of numbers, but nowadays new scales have developed. And for this is the advantage that all they are included in the sample, they have the same representation of their population. But this advantage is there. It is difficult to identify every member of the population. So for that situation, we have the new kind of sampling method. Next slide. This is an example, kind of sickle cell anemia. So we can have the all patients who have the sickle cell anemia and who have admitted in a hospital or maybe in clinic. So in that situation, we can collect the information of the patient and can make a sampling frame, and we can have some measurement of them. So next slide. It is the systematic random sampling. So it is very famous. So what happened in the systematic random samplings? Uh, we can have done specific statistical tools. How? Suppose we have a large number of population. We have to take some samples from there. In that situation, what we do in that case, we make a random so
Sir, you're not audible.
hello,
Yes, sir.
I am audible.
Yes, sir.
Okay, go to the next slide. Yeah, so this is an interesting example. So suppose we want to study 500 students from a school and their total number of students is 10,000. And in that case, if we in that case we want to do, suppose we are not doing simple random sampling, we are doing stratified random sampling. So in that case, what we have, we need to have the information about the random interval. So in that case, a statistical measurement is there. We will take an interval based on the total number of population that is divided by the number of students will be carried out. So that is 10,000 by 500, that is 20. So in that case, we have the information of the whole 10,000 students, and we will collect the information of the students based on this interval. And 20, and at the first means at first which students will be included in the sample. In that case, we will select a random number that is between 1 to end of this random number, means 1 to 20, this interval. So we have to take a random number between 1 to 20. Suppose it is 8. So we will take the next students, that 8 plus 20 means first random number is 8. We will add this number with the interval that is 20. So the first student will come the 8th students in the list. So we have list of all 10,000 students. So in that case, we call it a sampling frame. So that is similar to the sampling frame because the whole information we have. And we have the interval also that we can calculate from the sample, because we have to take only 500 students. So that is, in that case, our interval is 20. So we will take first the 8 and second 8 plus 20, that is 28. After that 28 plus 20, it is 48. After that plus 20, it is 68. So in that case, we'll collect up until we have the 1500 students. So these are nice development from the previous stage, that is systematic random sampling. Most of the days in various surveys also this kind of sampling is widely used. And the next slide. Next. Next. This is the example is given. That is 8, 28. After that 48. This is a sampling frame. You can see the whole information is here. This is kind of sampling frame. And if we are using these systematic sampling methods and using the intervals, and after that we can collect this 8th number, 28th number in this up to the 500 students we will have. Next slide. It is stratified random sampling. It is also very interesting random sampling. This is kind of, suppose we are studying a village, and if we can see that in many villages, people are staying kind of clusters, these kind of groups. In some villages, you can see these areas mostly are from uh, the kind of wages, daily labor people, and who are working on, suppose, in construction works. In another corner of the village, you can see a group of people. Most of the group of people that are living here, who are working on, suppose, bricks making, or suppose in jewelry works. So this is stratified random sampling based on that concept, based on the similar characteristics of the people. We go to the village, or we in medical study also, we go to any place. If we see the most of the people or most of the cases are the similar characteristics, so we will collect the sampled population from this area. That is the stratified random sampling. Because this area is stratified, these small groups are called the stratum, based on their similar kind of uh, characteristics. But one kind of disadvantage we have, because it is difficult to pick the appropriate strata. because individuals have the different kind of characteristics. So it is also difficult to pick the appropriate strata. Which strata have the most homogeneous population or most homogeneous kind of cases, and it is also very difficult to identify the every member of the population. This you can see this picture. We suppose a case of hypertension. So if we see in some groups, that is the mild cases, and groups with the moderate cases, and the groups with the severe cases, so we'll collect the samples from the mild cases, we'll collect the samples from the moderate cases, we'll collect the samples from the severe cases. So after that we will uh, collect their information. So this is basically the stratum. Mild is a stratum, moderate it is a stratum, severe it is a stratum. So it is called a stratified random sampling. So after that, again, next slide. So suppose here is the example of the dietary intake of adolescents. So we can take, because the most of the groups that is age 10 to 13, maybe the similar kind of characteristics they have. Groups 14 to 16, we divide three groups, 17 to 19, based on the adolescence ages. So 10 to 13, most of the child have the similar kind of characteristics what we see in common, in the common way. So we can stratify based on their ages, based on their groups, based on by their sex. So after that we can collect their information, and each every uh, groups is called here as a stratum. Next slide. That is cluster sampling. This is the last type of sampling. Next slide. Yeah, see this picture. So this is cluster sampling. Suppose that is a village or town area. So previously, what we have done uh, uh, in the stratified sampling, we divided or we characterized the groups based on their similar type of characteristics. But here we classified the groups only based on the natural boundaries. Means whatever the population is there, maybe similar kind of characteristics, maybe with different kind of characteristics, but we have divided the village or the areas based on some naturally bounded characteristics. So there is also statistical procedures how to classify this cluster. There should be at least this much population. There should be at least this kind of characteristics they should have. Means the way or the how we can cut the areas. There are different kind of things is there. I will not include here these things. That is also included in the mapping listing scenarios. That is a different portion of our station. So based on their uh, characteristics, the village or town areas are classified, and you can see that is these areas are classified into six sections: one, two, three, four, five sections. So every section has various kind of characteristics. So the advantage of having this kind of sampling, that there are very less chances of biases, and every kind of population, whether they are different from different religion, whether they are from different economic status, whether they are from different occupational status, everyone can represent their cluster. So that is the main advantage of this kind of sampling. So most of the surveys or socio-demographic studies, they are people using this kind of studies nowadays. Next slide. Next. So that is multi-stage sampling. Means what we have seen this random sampling, stratified sampling, systematic sampling, cluster sampling. Multi-stage means just we will use two kind of sampling in a one study. Means maybe stratified with cluster, maybe random with stratified. So in multiple stages we will use. So that is uh, in the NFHS or Demographic Health Survey, National Family Health Survey, they also use the multi-stage random sampling. At first they select, in the NFHS they select the states. After that they select the districts. So after that, within the districts they select the town or villages. After that they select the households. So they select the villages by one kind of probabilistic sampling. After that they select the households again with another probabilistic approach. So in one survey, if we use multiple kind of probabilistic sampling, that is the multi-stage random sampling. Next. Now I will say something about the non-probabilistic sampling. That is the quota sampling, mainly based on some specific characteristics of the people to whom we want to study. So suppose we want to study some school dropout candidates. We want to study the dropout candidates, or we want to study the anemic women. So in that cases, this kind of we can collect the information based on the specific situation. In that cases, probabilistic sampling will not work because they are not represents the whole population, or they are not represents their villages or towns, because this is the specific characteristics they have. That's why you are trying to explore the situation, what kind of problems they are facing. Next, the convenience sampling. So if we study, suppose some typical persons and some typical groups, maybe some psychological patients, maybe hypertension problems. So for the specific groups, for that purpose, means take them where you find them. Suppose we have to study on the old age population who are having specific kind of dementia. So it is very rare disease, but it is happening. We have this kind of problems here in our population. So we have to find out where this kind of situation is happening. We have to find the location. We have to find the specific people who have this kind of situation. So these kind of typical problems we have. So in that situation, we will also convince the people that we want to study this. There are lots of problems with the data collection or these kind of situations. So that is, this kind of sampling is basically for the specific case, for the specific situation. Next slide. This is purposive sampling. This kind of similar kind of sampling. That's the objective of your study or the purpose of your study. Who can represent your sample, go to the sample, talk to them, try to convince and fulfill your purpose. To suppose if we want to study the smokers, so it is also, you can see, or you can we have many smokers around us, but there is also some criteria we have to follow, to whom we have to include. So there is a solution that is called screening. In that case also we can use some random kind of inclusion of the representative samples that have, we can suppose we have a Excel sheet, we can include some we can list some of representative population, number one, number two, number three. We can suppose we have a 50 populations, or we have 50 number of samples with us. Suppose we are not studying the 50 whole, we can study among 15 or 20 among them. So we can take a depending on our purpose. So this is also very famous kind of sampling we have. And the next, this is the snowball sampling. Basically, snowball sampling is famous for illegal migrant study, for drug user study, or any kind of problems that is very rare. Because in snowball sampling, what happens if someone knows? Suppose I am a illegal migrant, so there is a high chance I know some people who are also illegal migrants. So the process of snowball sampling is come to that person who know about also the other person who are also illegal so again go to the second people and tell him to find out another people who is also the illegal migrants. So this is also some examples. Suppose this is a study risk factor of HIV-1 and HIV-2 infection in rural and urban areas of Tamil Nadu. So their objective is find the prevalence and risk factors of having HIV. So they are metropolitan cities and municipalities in Tamil Nadu, and their subject is individuals in Tamil Nadu. And their sampling procedures. So they what they did, it is a study done in 1998. It is also a very famous study. They did a health camps. This camp organized in 5 rural or 5 urban centers, and every third person screened like we had seen in systematic random sampling. That is kind of these things. They every third person they screened in the active reproductive age group was recruited as a subject. As each camp, the inclusion of the subjects continued until the 200 patients were recruited. So this kind of sampling we can have in the our purposive modeling also means within the purposive concept we can use some little bit of randomized things that we can have a little we can reduce our bias. Next, this is also another study. So open the next slide. Open the next slide.
So this one will, or should I switch to the third one?
Third one.
Okay.
So it is very important which kind of sampling we will have, which kind of whether it will be purposive, whether it will be snowball. That is based on our research question. That is based on our object. And in the probabilistic approach also, we have to take in such a way that our bias is used. So we have to take care of the situation, which kind of randomized sampling I am using. So next slide, that is how to calculate the sample size. Am I audible?
Yes, sir.
So this in this session we will know little bit about the sample size estimation things. Next slide. So at first we have seen that we have to what kind of sampling methodologies is there in probabilistic and non-probabilistic approach, and whenever we will go for study in that time the question comes that now we know that this kind of sampling methodology we are going to follow. So after that we have to take the sampled population. So how much the sample size should be, or what is the exact procedure for having the sample size. So in this situation we'll follow some statistical measurements. So sample size actually is required to answer how much or what is the valid representation of the whole population. So to show that the study has a reasonable chance to obtain a conclusive result, because based on this sample size the whole study will interpret. From here we interpret the result and we infer, and after that the program policy whatever will come into the picture based on the sample size. So if we make error or wrong on calculating the sample size, the whole conclusion will means it will be waste. To show that the necessary resources, that is human, monetary time, that will be minimized and well utilized. So that will all be wasted if we cannot do it better way. So next slide. So sample size. So sometimes we also heard that many people say, this much sample, it will be too big, or only this much, it will be too small. So it is not a magic number. It is a logical number. It is a scientific number. It is a statistical number that will help you to understand the whole scenario of the population. So don't think about this too much, or it will be it's too small, or it is the magic, or whatever we suppose we are going to study. Let's take 50 or let's take 60. Not kind of that. It is not a any magical number. It's based on logic. It's based on calculation. So next slide. So next slide, just I told these things. So where do we get this knowledge? So suppose we are going for studying suppose we are going to study the anemic woman, or maybe the stunting child. So from where we get the knowledge that how much should be the size of my sample. So for that case, we need the formula is there. So for calculating the sample size, we have to know the prior prevalence of that disease or that problem. Suppose we want to study anemic women, some states. So for that purpose, we should have some basic knowledge about the prevalence of anemia, means how much people are getting, how much women are getting anemic on that area for the last few years. Some little sense we should have for getting this kind of epidemiological or public health study. For that purpose, generally we use the previous published works. Sometimes, suppose there is no published work, so this time we use the pilot studies on that situation. So in that situation for the pilot study, so in the pilot study there are not too much restrictions is there. Generally we do based on our objectives, and if information is lacking, there is no good way to calculate the sample size. If we have some previous published results or some prevalences about the situation, current situation, in that situation we can have a better sample size. Next slide. So next slide. So in that situations also, this is what I told you. In the sampling cases, obviously will be some error. So in that's in the biostatistical research what we are doing. There are mainly two kind of errors we are having. First one the type 1 error, and second one the type 2 error. So type 1 error means the false positive things. Suppose we are studying on some pregnant woman, and pregnant woman this goes to doctor, and doctor did some basic diagnostics, and uh, these diagnosis results got that the so this is in the statistical scenario, it is called the false positive results. Actually, this disease not had, but result is showing is a positive result. So this is a false positive result. So this is very what dangerous for us. It is called a type 1 error. And in the next slide, this type 2 error is that is not finding such a difference in the actual exist between two groups. This is the false negative. What negative kind of results is coming? It is false. Actually, she was pregnant, but the result is coming. It is false. It's type 2 error. So in any study, we are saying that type 1 is there, type 2 is there, but for our purpose, every time we try to minimize our errors, it is we have to minimize the type 1 error, we have to minimize the type 2 error. So we first always try to minimize the type 1 error, try to that is the table figure that is uh, in the right side you can see the significant difference that is test results, that is type 1 error means the disease is absent but the test result is shows the positive. Okay, like uh, in the type 2 error is the disease is there but the result is shows the negative. Go to the next slide. Here, see the picture. In the innocent case, means the disease is not there. She is not, he is not given, but the result is showing is positive. Result means he has given to jail. So this is in our statistical measurement. It is type 1 error. Means he is innocent, though he is got jailed. It's type 1 error. And the second case, type 2 error, he is not innocent, but he is got set free. It's type 2 error. So always type 1 error, we should minimize, or we always want to make it minimize the type 1 error. Means we should not give him, should not give him a travel, whether means though he is not means made any guilty. So in any statistical analysis, always try to reduce the type 1 error. After that, try to reduce the type 2 error. And though two are interlinked. Next slide. That is estimation of sample size by three ways. So we estimate it by manual formula. We can estimate is using some tables is there, statistical tables, and we can use some software. G star power is a very nice software is there. We can estimate is also there. Next slide. This is the sample size calculation formula for proportion. Proportion means suppose we are trying to study stunting child, we are trying to study the hypertension hypertension groups, we are trying to study dementia patients, we are trying to study anemic patients, or we are trying to study tuberculosis problems. So everywhere I told you that the some prior information we need means the prevalence, how much people are getting affected. So that is the value of P. The formula you are seeing that N equals to Z square PQ by D square. Here P is that prevalence or proportion of the target population that we need some prior knowledge of that population. Maybe we can have from the previous studies, and or otherwise if there is no such study, we can do some primary study to get the basic idea. So it is very important to have basic knowledge about this population. And Z is the standard normal deviation. Significant level means how much confident we are, means if we are taking the 100 cases, so at least for the 95% cases we should have this kind of scenario or the similar characteristics. This is the 95% confidence level. So in that cases the value of Z is 1.96. We consider while we take the 99% confidence, that is the 2.58 the Z value. But most of the statistical analysis, we generally use the 95% confidence level, that is 1.96 Z value. Means around 95% cases, we are sure that we have the similar kind of characteristics according to our objective. And P is, I told you, P is the prevalence or proportion of the target population, that we can have the idea from the previous studies. And D is the, and Q is the just 1 minus P is the transpose of that population, and D is the precision or accuracy. And D is the precision or accuracy of that sampling frame. And it is a, suppose we are trying to study an average weight in a population, average weight in a class 5 students average weight. So in that scenario, we do not need any previous information or previous prevalences or previous proportions. So in that cases, we can use simple this kind of formula. Here only the change is the A is the standard deviation, because the mean value, the average value of that class, that how much deviates from the mean value from the other values. Next slide. Suppose that is a problem. It was desired to estimate the proportion of anemic children in a certain preparatory school. In a similar study to another school, a proportion of 30% was detected. Then to compute the minimal sample size required at a confidence level of 95% and acceptance of difference up to 4% is d value of a true population. So in that cases, how we will calculate the sample size, that is proportion p value, that is 30% means 0.3 we can use, that is 95% cases Z value is 1. To the next slide, we have the proportion of to be estimated, it is 30%, D is 4% means it is in 0.04, and Z value is 1.9 critical value case. So if we put these numbers into that formula, we will have 504. This is the absolute number. It is also cases for lost. Suppose we are going to study for anemic patients. So there is high chance, if we want to follow up the case, there is high chance the missing the previous samples which many one will not respond in your questions. So in that cases, some non-response error also included, that is maybe 10 to 20%. So we generally include again the 20% or the 10% of this 500. So 10% of this 500 is 50, or 20% maybe 100. So always we should have this 10 or 20% non-response you have to add to your sample, that you after losing your cases, you should have minimum this kind of at least 500 cases in your hand. Next slide. So there is comparison of two means also. Suppose we are comparing two groups. One groups with here the example is the feeding extra kind of milk dieting, and another is normal. Suppose we are giving two treatments. We are giving one treatment is there and another placebo treatment. Placebo is there. So if we compare two different kind of situation, maybe treatment A, treatment B, maybe cases maybe with control, maybe treatment with placebo. So in that cases, two different group is there, and we want to compare the means of these two different groups, whether which treatment will works fine, which kind of medicine works fine. So in that cases, also different formula is there. Next slide. That is the formula. Using that formula, that is Z alpha for first case, Z beta for the second case, P1 first case, Q1 first case, P2 for this P and P for prevalences for these cases like same yes I told. And after putting the values here, you can get the sample size from this sample formula. Next slide. So this is also another problem. This problem is saying a study is to be done to determine effect of two drugs, that is A and B, on blood glucose level. From previous studies using those doses, drugs, standard deviation of this BL of A, that is 8 and 12 gram per deciliter, they were obtained at a significant level of 95% and power 90%. So we want to detect a mean difference between two groups. So how many subjects should be included in each group? So that is also we have these p values is there, that is 8, that is 12. We also have the Z values, that is for 95% it is 1.96. We have also power values. These values comes from a table. Statistical table is also there. So using this we can have the samples. Next, there you can see the calculation is given here, p value here. It is for the treatment A, that is given, for the treatment B also given. So p1 value, so here we considered the first cases the 60% and second cases for the 70%, treatment A for the 70%, treatment B 60%. So p1 for the first cases, here we can take the converse also. P1 is the 60% we consider. We can take the P1 for 0.7 also, vice versa. That is no problem. Just transpose the of the results. So after that, Z value is there. P and Q value is just P value. So after calculating, this value is 670. So I told that we have to consider about the non-response errors or non-response cases also, or lost in follow-up case also. So generally 20% extra sample we consider in that case for the dropout cases. So that will also be added in this adding with this 670. Next slide. So it is always remember that the pilot study do not need the sample size calculation. We can generally, when with the pilot study, when we do not have any previous idea of the sample population or the we do not require the number. So in that case, just we are having for the idea, we are taking these pilot studies, and sample size is an educated guess, and it works if the samples comes from the same or similar populations. If we take from population from this side, another one for the another cases, in that cases it will not work. It should have the homogeneous kind of situation. It should have the very much logical with your objectives, and it should have the representative of your population. In that cases, only your sample size will work, and in that cases, your conclusion will be valid and reliable. Otherwise, your study will not be successful. Hello? Hello?
হ্যাঁ হ্যাঁ বলো দাদা।
Acha. And the last thing is there, that is sampling methods. So should I, this slide is completed, and the last case is how we will analyze the data. So wait. This is the one thing I have to say, that you have to define the research question very well, and you have to careful about your study design, your response variable, your outcome variable, and you have to very careful about your analytical methods. So another thing is that there is also a software that is G Star Power. That is also very good software. So it is very time consuming also to understand this software. So after this, taking the sample size ideas, next thing will go to the sampling methods. But is time will permit or not? Or
Yes দাদা, go ahead.
okay, the next slide you open, that is the sampling method.
Is it visible?
Hi, visible. It is make the PPT presentation mode. Next slide. So so up to so at first we have seen the uh, sampling methodology, how we'll collect the data. After that, we have seen implementing the sampling method, how we calculate the sample size, how much or what should be the uh, sampling procedures. So after that, collecting the data, or after having the sample size, we'll collect the data, and after having the data, we'll analyze the data. So here I will tell you related to some data interpretation and analytical perspectives of the collected data. So these data are that we are collecting. These data have many kind of characteristics. It may be in words, it may be in numbers, it may be images. So we have to set the data for our analytical purpose. So after collecting the data, so we can collect the data from surveys or census, experiments, external source. So what kind of data we are collecting? We ourselves from the field. It is called the primary data. It may be observation, maybe interview, it may be survey. So and if someone collected the data and we are using this data, that is called the secondary data. Suppose we are using the census data. So that is it is secondary data for me. If myself is doing a study in a hospital or in a clinical setup or in field, myself doing, that is the primary data. And whenever we are, suppose my friend is doing a survey, I am using his data. So that data is, for me it is secondary data, but for friends it is primary data. So we have to take the idea of the data what kind of data we are going to have to use. Next slide. Next slide. Next. Hello.
1 minute.
Okay. Visible. But make it
দাদা আমি
presentation.
আমি প্রেজেন্টেশন নোটটা করছি না, তাহলে হ্যাং করছে।
Okay, fine, no problem. So that is the, so after having the data, we have to check which kind of data it is. It is qualitative data or it is quantitative data. So whenever we will make a research plan, so question will ask which kind of information we are having to for our study. So in that time in our mind that we are having qualitative data or we are going to have the quantitative data. So whenever we will make the questionnaire, we will make the questionnaire in such a way whether it will be qualitative or whether it will be quantitative. Next slide. So in the qualitative data means it is based on some attributes, maybe sex, male, female, maybe exam results, pass, fail, maybe blood groups, maybe color of eyes, maybe, because it is not a number, it is not numerical, it is not a number, it is an attribute, it is a character. Next. And in ordinal, within the attribute, two kind of, one is nominal, another is ordinal. These ordinal cases, this means response to the treatment is poor, fair, or good, or according the severity of the disease, mild, moderate, or severe, or income level. So these are the qualitative information for us. And what is the quantitative information? Next slide. That is based on the numbers, that is kind of total number of family members, total number of heartbeats, total number of admissions. This is a number, we can say 2, 5, 10, 20. So this is different from different kind of data structure we have. And it is some, we have some quantitative continuous data also. Age, serum cholesterol or BMI, because there that is not a, someone will say that this value is 0 point something, another one will say that this value is 0 point something. So show me the okay. So this is the continuous scale. In that picture it is clear. If we see the number event, we can tell it is 5, it is 10, it is 2, or it is 6. But when it is a for hemoglobin case or other things, heartbeat case, so it may be anything within that range. So it is too much continuous kind of. Next slide. And sometimes for our analytical purpose, we make our qualitative formal. suppose in heights, in weights, we make some groups or we make some scales. From this to this, we can say it this. From this to this, we can say it normal. From this to this, we can say it obese. So we can make some scale. So from continuous, we can make it some qualitative also. Next slide. So based on our object, suppose it is a hospital length of a stay. So it is maybe a continuous 1, 2, 3, 4, 5, 6, 7, 8 kind of. So we made a we scale within 1 to 3 days. We made a group. 4 to 7 days we made a group. So in that case, in that type, by using this scale, we can make some different distributions also. Means we can change our data structure also after having our data depending on our object. Next slide. So this is variable. Variable means what is what is our study purpose, what is our outcome, what is our control variable, what is our main predictor. Means what are going to suppose the effect of smoking on lung cancer. So we are going to study the lung cancer. So our outcome variable is lung cancer, and our predictors, main predictor is having smoking. So lung cancer depends on smoking. So and another control variables also we have. So this information what we are going to study, these are attributed to variables, outcome variables, predictor variables. Next slide. Variables categorized on their characteristics. Suppose what I say, the risk factor hypertension. So we are exploring the hypertension. We want to know about the hypertension as an outcome variable. So it is depends. Hypertension is depends our lifestyle. Hypertension is depends our occupational things. Hypertension depends our socio-cultural background. So hypertension our dependent variable, and another these variables are called the independent variables, which affects the hypertensions maybe directly or indirectly. Next. So we have, after data collection, we have the statistics, how to interpret or how to understand our data. After that, we will infer our data. After that, we will do some analysis to give the interpretation of collected samples. Next. So how to understand the data? So this is the first step we do in every survey or in every data. At the first stage, we do the frequency distribution. We want to see the how the data is distributed, what kind of distribution or what kind of sampled are in my data. So the first step is to have the frequency distribution, means to see the center, to see the ranges from these to these are varies, the shape, uh, what is the midpoint, how much the non-response. So at first we have to try, we have to get the idea of the data which we have. Next, that is the frequency distribution of adult patients by hemoglobin and gender. So that is, you can see gender wise also given. This is the kind of frequency table. So everywhere when we are going to study any cases, maybe any diseases or any population, at the first look, we have to see, we have to check the frequency that we get an idea that this you can see also in these ages or in this population, this is high. So after that, the research questions will come very better way in your mind that you can do these things or why these things are so high. Anything other problems that we can study. So This is very important things to have. Next slide. That is elements of a table. So what in a table, what should have? Number, title, percentage, how much the range. This is we need in a frequency table. Next slide. Next, we can see by diagrams also. So there are different kind of diagrams: histogram, frequency polygon, box plot, different kind of diagram we can create using this raw data. Next slide. If we see, it is called a histogram, just based on ages. So based on the ages of 60 subjects, getting marks of 60 subjects, there is a basic histogram is drawn. So we can have a primary idea of our data. In that ages, the marks are having is very high. So it is very important to formalize your research questions. So it is very important to see the basic characteristics of your data. Next, this polygon. This is similar kind of figure. Next, it is descriptive statistics. Whenever you will read a research paper, every research paper you will see the first table of their paper is a descriptive statistics of their sampled population of their study population. So in descriptive statistics, what is given that how much the sample size, that is number of observations, what is the mean for the every variable, that is also given, what is the standard deviation, how much is deviated from the mean, that is also given, what is the minimum value, what is the maximum value of every variable, that is also very important. So descriptive table is given, provided for every paper. It is very interesting and it is very uh, it is gives a snapshot at a basic level that your sample is this kind of looking. It's very good for having this kind of table. Next, pie chart. It is also kind of chart that you can say is this percent of population, like 70% of population having severe problems of hypertension, that's 20% of population are having moderate level of hypertension, and this kind of the total 100%, and based on their category, this pie chart is generated. We have also learned in primary schools also how we can get the angles based on 360-degree kind of similar to pie chart. Next slide. That is a bar graph. It is mainly for the qualitative data based on the specific attributes. We have given it for this attribute this much of people, for this attribute this much of people. This is the basic bar graphs. Y-axis and the category in the x-axis. Next slide. This is HIV cases enrolled in US by gender. This is called bar chart. This is for men, and for women, there is much proportion is by the years is increasing or decreasing. You can see and by one picture very quickly. Next. So, follow this picture. For mainly for the quantitative data, this frequency polygon and histogram is drawn, and for the bar diagram, we generally use the qualitative data. So this is the graphical presentation. We have seen this session is very good for the basic representations of your data, and it is necessary. It is mandatory also. Next. So I have also I told also that sometimes we make quantitative data into the qualitative also, heights into three different categories: short, medium, tall, weight also three different categories. So we can make it as per demand or our object and nothing else. So it depends on you how many category you will make based on. Sometimes generally we follow the guidelines. Suppose WHO's guidelines or another kind of guidelines that they are saying that this kind of category you can follow for any kind of disease. Next slide. So there's after getting the data, after having this kind of frequency distributions, so we tell that how this data is distributed. Is it normally distributed or is it any other else? So for that purpose, we comes to the picture, the distribution, how this data is distributed. Next slide. So based on the distribution also, so suppose when we are going to study, there are some basic research questions we have. Suppose we are studying the effect of smoking on lung cancer. So our hypothesis is that there is no association between lung cancer and smoke. So at first, whenever we do something, we start from the beginning, considering something. We are considering these things. After that, we go to check this hypothesis, whether this hypothesis holds or not. Our analytical results will hold our hypothesis or not. So based on our statistical data, we will test our hypothesis whether smoking affects our lung or not, this kind of. So hypothesis is very much important for any analysis for the basic steps, because based on our hypothesis, we will go further. Next. So testing hypothesis are various steps. At first, take the null hypothesis, then choose your statistical model based on your data, whether it will follow the normal distribution or you will follow the chi-square distribution or t distribution for your analysis, or how much level of significance you will follow. So based on every steps it will be followed, how whether your hypothesis holds or not. Next slide. Yeah. So there is also three types of mainly hypothesis. One is the null hypothesis. That is, I said the null in suppose in our studies for smoking cases. So null hypothesis we can consider is smoking rate in male is equal to the smoking rate in females or women. Or alternative hypothesis also means not equal to, maybe greater than, maybe less than, or maybe not equal. So whenever the not equal to cases comes, the smoking rate in male is not equal to the smoking rate in women. It is called a two-tailed cases. And interesting thing is that you can take any kind of null hypothesis. You can take this second point, men greater than women. You can take this one also, the null hypothesis. There is no tight bound criteria that you have to take this one. But generally, we used to take the equal one, but there is no association, or there is equal association, this kind of. But there is no harm rule. You can take any criteria as a null hypothesis. Second, next slide. And another concept is p-value. P-value means p-value varies from 0 to 1. 0 cases means there is no chance it happening on this. 1 means certain case it will happen, 100% sure. So based on their p-value, whenever we perform any statistical analysis, it gives the p-values us, means how much the chance of happening of this situation which we are going to study. See, p-value, depending on this p-value, we define whether this null hypothesis stands, holds, or not. If p-value is 0.01, it means that it represents 1 in one case in 100 cases. That is possible that results have occurred by chance. 0.05 means 1 in 20 or 5 in 100 cases chances that could have occurred in that case. So p-value is very much important. In every study you will see in analytical results, they say everything based on p-value. Next slide. Next slide. That is, after that having these things, we'll see some statistical inference. Next slide. So we'll estimate our uh, survey statistics. Statistics means statistic, that is the nature of our sample population, that I will compare with the population characteristics. So there are two kind of estimation, that is parametric estimation and another is non-parametric estimation. Basically parametric kind of central tendency. So in parametric estimation, the inferences are drawn about the parameters in the target population. And in the non-parametric estimations, go to the next slide. That is, it is the confidence intervals. Confidence intervals means how much the deviation of your mean. Means if you calculate the mean of your class 5 students, height or maybe in weight, everyone mean height or mean weight comes the unique number, means one digit, means single number. But every student, other students will not have the similar heights or the similar weights. Every individual have the different heights and different weights. So CI gives the deviation, means ranges from this point to this point. From any, means if we have a mean and we have a CI, we can tell that these people, this class have ranges of their heights between these to these, or between these to this their weight. Next slide. It is also given. Generally, parametric distribution used for the continuous data. Data belongs to the interval or ratio, and generally it is most powerful and it is highly demandable. And the non-parametric data, it is basically for the discrete data and it comes for the nominal or on-year scales, and for the maybe words, maybe text. And it is comparatively less powerful than the parametric. Next slide. Uh, And for the parametric test, there are various kind of tests for the sample statistics. Tests. T-test means nothing but testing their means. ANOVA means analysis of their variance, how much the deviation, and linear regression, various kind of regression. In the non-parametric cases, chi-square is there, man-Whitney test, various Wisconsin test is very famous in biostatistics. Friedman's, Spearman's correlation test, logistic regression. Next slide. And this is the correlation. Correlation means if we are having a study, there are various variables in the study, and if we study the outcome, so in that situation we generally we correlate or try to understand the correlation among the variables which indirectly or directly correlated with the outcome. So correlation is very much important. It depends the uh, situation from where you collected the data. Correlation is very much important, and there are different kind of correlational analysis also there. Next slide. You can see this picture also. This kind of correlational pictorial or diagram we have in data is based on our outcome and this independent variable. And sometimes you see that outlier is also there. So it also clears the distribution of your data. If some data is too much scattered, so we try to clean and sort the data in that case, we can get a better estimate of our objectives. Next slide. That is regression. So it is the last step of our analysis, means how the independent variables affects the outcomes, means that is the dependent variable. So there are different kind of regression method is there. Next slide. If the dependent variables, suppose anyone is anemic or not. If our dependent variable, outcome variable is anemia, so our dependent variable will be binomial mode, 0 or 1, anemic, yes or no. So if our dependent variable in categorical, means depends on 0 or 1 kind of situation, and our independent variable is continuous, maybe any kind of, maybe age, maybe maybe BP, BMI. So in that cases, our regression, analytical regression, it will be logistic regression. And for the uh, uh, continuous cases, it will be only the linear regression. Means continuous cases means our outcome will not be categorized into 0 and 1. Yes and no. This kind of situation will happen only in logistic regression cases. But whenever your outcome variable is continuous, you cannot use the logistic regression. You have to use the linear regression. Next. It is a linear regression. That is also, it follows the normality. That's why it can use the parametric test. Our independent variable will be the follow for your analysis. Next slide. This is the simple equation for the linear regression, that is y equals to a plus bs. Here y is the dependent variable, because anemic, yes or in linear cases it will not work, because in linear cases it has to be a continuous variable. So maybe BMI. So and a is a plus bx. Here a is the intercept and PCD is the coefficients of the regression. Here x is your independent variable. It may be your socio cultural background. It may be your economical background. It may be your lifestyle lifestyle attitudes. So y is your outcome and x is your control independent variable. So if you have multiple independent variables or multiple controls, so see the last equation, y equal to a plus bx1 plus x2 plus dx3. X1 will be another independent variable, x2 will be another, x3 will be another. In such a way, we can make a linear regression. Next. It is also an example is given. So A is intercept, B is the coefficient, and X is age, your independent variable. If age of a man is 50, just use the 50 in the place of age, you will get the value of Y, that is outcome. Probably the question is given the previous slide. Okay, so go to the next slide. So output of the linear equation. So how to give the out? I will give an example later. Probably example comes later. Next. And what just go to the previous slide. Just one thing I have to say, that is R square. That is R square. It is coefficient of determination. It's very important in any exam. R square gives you R square value whenever you do your analysis in statistical software. That software or analysis integration gives the R square value, and this R square value is when you are using your control or independent variables to see the effects of keeping the outcome variables, how your control variables presents your outcome variables. That is the R square value. How your analysis gives you the idea about your uh, selected variables used in the study. That is very much important. So sometimes we, based on R square value, we try to develop our model. We try to develop our control variables, or we try to develop our outcome. So R square value is very much important. How it explains your study, that is requires. Next. That is logistic regression. Logistic regression is widely used in any public health research. You can see in socio-economic research also. So in that case, your dependent variable means your outcome variable, which variable you are going to study. It should be categorical, means yes or no, 0 or 1, this kind of situation. And your independent variable, you should have in discrete or continuous. And these are non-linear regression, and dependent variable and independent variable, this correlation is not required, and large sample size is required. Basically, in the normal distribution, we say that n should, number of samples should be more than 30. Various lot, obviously most of the cases we have is more than 30 cases, and multicollinearity and outlier should be absent. So if we check the collinear graph diagram, so in that situation we can check the multicollinearity problem, or outliers there we can identify, and if outliers there we can short the data. So these graphical pictorial presentations also helps to improve our statistical perspectives. Next slide. That is the equation for logistic regression. Uh, P for the evidences of what we are going to study. Here we used the hypercholesterol, and this is x1, x2, that is the other control or independent variables. Here it is calorie intake, physical activity, BMI, and this B, C, D you are seeing, you have seen here is the coefficient. So whenever you will get the results. So suppose B value is 0.5. So you will take 1 unit increase in calorie intake, your hypercholesterol will increase by 0.5, kind of that. So based on these coefficients, you will get from the statistical analysis, based on this coefficient, your interpretation. Very much important to understand the coefficient. Next. The output. Same the R square, I told you the R square, odd ratio also this kind of this what I told you about coefficients, we can interpret our data also using odd ratio. This odd ratio generally comes whenever the positive odd ratio means this affects the positive, means positive way. This increase means this also will increase. Negative way means this increase means that will decrease. The outcome will decrease. So odd ratio and the coefficients. These two are mainly used in the results and interpretation purpose of any analytical method. Next, this is the type of regression. This is dependent variable. I told you the main objective of your study is dichotomous polytotomous, that is binary logistic. Dichotomous in binary case 0 and 1, and your it's multiple kind of state, that is multinomial logistic regression you can use is 0, 1, 2 kind of. Next slide. That is simple regression, one independent variable, multiple regression, four more independent variables. That is the basic you have to know while your analytical process is, and this is end of my presentation. Next slide. So is full, or I already I shared the Dattatreya. We will share you one, and if you have any question you can ask, and you can collect my mail ID. If you have any questions further related to public health and biomedical things. Actually, it's very tough to discuss within 1 or 2 hours. lots of.
Thank you, sir, for this elaborative and insightful session. And yeah, the floor is open for the question. If anyone has any question, put that in the chat box. And we also prepared a few questions from our side also. So can you answer?
Yeah.
Okay, sir. So could you share any practical tips or tools for selecting the appropriate statistical method for a given biomedical data set?
Uh, there are various statistical. You are saying about statistical tools means software or software or related these things, or
Yes, sir.
there are the various kind of softwares, G-Star or these things. But for using this software, you have to prepare about your prevalence value, because this kind of what kind of calculations I have shown you manually. This for two means cases or proportion value cases. So this software, they they made these things into their process. This they only calculate for you, but you have to give you the prevalence value, like p value, and what kind of CI you need, what kind of confidence interval it is, Z value what should be, that the software will ask you, because software does not know that the prevalence of these things what you are going to study. So that basically they are calculating for you, and you do not have to calculate manually. That's the thing. So there are software that is G Star, and another software is there. If Dattatreya arrange in another day, that I can tell you the G Star also. That is also nice software, but all things based on your this things that is done within the software.
Yeah, thank you, sir.
But the basic information you have to give, because software does not know about your cases or their prevalences.
Okay, thank you, sir. So, how important is it for medical researchers to have in-depth statistical knowledge or in collaboration with statistician enough?
It is very much important, because most of the cases what we do, what generally numbers does not tell the actual truth. Numbers will give you the picture, a snapshot of the situation, the what is going on, what is the trend, what is the basic scenario, these things, and what some related variables, this related to this, this related to this. But if you go to the in-depth study, uh, maybe some qualitative cases, you will get interesting results, and based on these interesting results, you can go too much further. Sometimes you will see that your in-depth results will contradict your numerical results also, because numbers does not give you the actual scenario in many cases, because the uh, on field which is also different, because we are collecting the large number of data. That's why biases are we are having the less biases. So common trend we can get from the large scale data. But it is also very interesting if we get some scale qualitative data study also. It is very fruitful. And you can see also this cholera.map and Bradford study. Somewhere some cases are very less, but they are doing very long study, maybe 50 years, 100 years. Also, I have read some study using very few cases. So deep studies very much in many cases.
Thank you, sir. So, last question from our side. In your experience, what is the most common mistake young researchers make when calculating sample size or data?
Most of the young researchers means what is the basic idea of calculating sample size, it is missing. Most of the cases I have seen that they are taking some random numbers, or they are taking numbers without any scientific logic. And generally, whenever we are comes from the statistics background, we know if we take this kind of any random number, so there may be high sampling errors, there may be high having biases. So we have to understand at first, based on the objectives, what we are going to do, and for that purpose what kind of sampling methodology we have to follow, and after that in which way we can take the sample that we can have the less biases and the most full estimates that we can have. So for that purpose, we have to read about these things about the sample size calculation, having the sample size method. I think these medical sciences also they have some courses there. So I think everyone should know about the problems of having any kind of numbers, not the magic number. If logic, every steps have taking these numbers. So that's why I have tried just taking every stage into a short PPT. So it is very essential to know the logic behind taking the numbers. So I think it is very fruitful if everyone will go through this kind of uh, scientific way and measurement process.
Thank you, sir. Thank you so much. So, as we come to the end of this session, I would like to extend our